Hey everyone, this is Mr. Janes. In this video, we're going to be talking about the properties of tangents and chords. There are three important properties about tangents and chords that you need to know in order to do some algebraic and some more conceptual problems. So, what I'll do is I'll explain each of the properties, then you can pause the video and try a couple of the problems using the properties. Then, unpause the video to see if you got them right. Here we go. The first property is if a radius is perpendicular to a chord, then it bisects that chord. What does that mean? Well, let's take a look at the circle over here. Here's a radius in red, and here's a chord in blue. And the radius is going to be perpendicular to that chord, just like that. Now, if the radius is perpendicular to the chord, it bisects it. It cuts it into two congruent halves. If you understand what I'm saying there, go ahead and try the two problems below. If not, keep watching right now and don't pause the video. So let's start with the first problem. Here we've got a radius in red, and my chord is in blue, and they need to know what x is. Well, the radius is perpendicular to the chord, which means that the chord is cut in half. It's bisected. So if this half is 6, x will also be 6, and the length of the entire chord would be 12. Now, we don't know any information about this length right here, and we don't know any information about this length right there. Nothing about those. Fortunately, they didn't ask us about those, so we're good to go. Let's look at the next problem. Here they want to find out what x is. So here's my chord again. Okay. And unfortunately, I don't know what this is over here. I don't know what any part of the chord is, so I can't actually use this property to find x. Fortunately, if you look closely, you'll see that there is a right triangle here with two of the sides that are labeled. And what can we do with a right triangle? Well, we can use Pythagorean theorem. So pause right now if you'd like and try Pythagorean theorem. Hopefully, you should get something that looks like this. 8.3 squared plus x squared equals 20.4 squared. And if you do your math correctly and solve it out, you should get x is approximately equal to 18.64. And that is the first property. Let's take a look at the second property. A tangent line is perpendicular to the radius at the point of tangency. What does that mean? Well, let me show you. Here in our circle, this is a radius. There it is. And in purple here, I'll put a tangent line. Right? Just touches that circle once and keeps going. Now, what I'm telling you is that the radius and that tangent line are always perpendicular. That is, they form a 90-degree angle. If you think you can understand that, go ahead and try the next two problems. Otherwise, keep watching. In the diagram, ray TP is tangent to circle D. Determine the measure of angle DTP. So they want to know what this is. DTP. I don't know what that is. We don't know. What do we know? Well, we just learned that the radius and the tangent line are perpendicular. So, here's a radius, here's a tangent line, they're perpendicular, so let me put in my right angle right here. Good. And what else can I do? Well, I know that this is 120 degrees, so there's a supplementary angle over there. So that'll be 120 minus 180 is 60 degrees. And I know that all of the angles in a triangle add to 180. So I've got 60. I've got that right angle, that's 90 right there, which means, let's see, 180 minus 60 minus 90, that angle will be 30 degrees. All right, that angle's 30 degrees. Let's look at the next one. In the diagram, CA is tangent to circle P. The radius of circle P is 8 centimeters, and BC equals 9 centimeters. AC equals blank. So let's label those. The radius of circle P is 8 centimeters. So this is a radius right there. This is also a radius right there. And BC is 9 centimeters. And AC equals what? Okay, X. We'll put an X there. How can I figure that out? Well, let's remember what we learned before. A tangent line is perpendicular to the radius. So here's a radius. Here's a tangent line. I could drop a right angle right here. Boom. Oh, and hey, look, I've got a right triangle. What do we know about right triangles? You can use Pythagorean theorem. So I've got a side that has a length of 8, a side that has a length of, let's see, 8 plus 9, that'll be 17, and I don't know the last side. So we can write out Pythagorean theorem. If you'd like to pause the video here and write out your answer, you can do that. Otherwise, keep watching. You should have something like 8 squared plus x squared equals, let's see, 17 squared. And after you solve, you should end up with x equals 15. All right. There we go. X equals 15. That ends property 2. Let's take a look at the third and final property. Two tangent segments to a circle from a point outside the circle are congruent. That's a little confusing. What does that mean? Well, here's what it means. If I have two tangent lines, here's a tangent line right there, and there's another tangent line right there. Okay, they just skim the circle at those points. And they intersect out here. This line right here, and this segment right here, there to there, there to there, are congruent. They kind of form an isosceles triangle. If you have something that's circular, you can kind of see this for yourself. Take a circle, and take two pens or pencils, and put them tangent to that circle. Now you can kind of tell that right here, it forms an isosceles triangle, which is exactly what this property is all about. In this diagram, so let's take a look at these two problems. Again, pause the video if you'd like to try these first. In the diagram, NM and QN are tangent to circle P. The radius of the circle P is 5 centimeters, and MN equals 12 centimeters. What is QN? Well, let's label everything. We know that the radius is 5 centimeters. We know that MN is 12 centimeters. Okay, and since this is tangent, that's going to be a right angle there. Okay. Well, we just learned that two tangent lines that intersect are congruent. So QN is also 12. Okay, second one. In the diagram below, AH, AD, and DH are each tangent to the circle Q. AT equals 9. Okay, AT equals 9. AH equals 13. AD equals 15. And what is HD? Well, here's how we can figure this out. Since TA is 9, MA is also 9. Since DA is 15 and MA is 9, we can subtract to figure out that DM is 6. Since TA is 9 and HA is 13, we can subtract to find out that HT is 4. Because we just learned that two tangent segments from a point outside the circle are congruent, if HT is 4, this right here is also 4. Since DM is 6, this right here is also 6. And now we know that H to D adds up to a total of 10. Good luck. Make sure you take the quiz before you finish the homework. I'll see you next class.